Hey guys, this is AF and in this video we are going to be discussing factors. In the previous video we discussed the different types of numbers, and in the next video we are going to be discussing multiples. Together these three videos are going to sum up the syllabus content for the first chapter, numbers. Moving on, let's discuss the concept of prime factorization. So prime factorization is basically the process in which we find out the prime factors of a number, and then we can even express that number as a product of its prime factors. 24, for example, can be expressed as 2 cubed multiplied by 3. In this expression, we have basically expressed 24 as a product of its prime factors, which are 2 and 3. So 24 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. Now the next question comes up, which numbers have prime factors and therefore which numbers can be expressed as a product of their prime factors? And the answer is that every natural number is going to have a certain number of prime factors and can be expressed as a product of its prime factors. We know this due to the fundamental theorem of arithmetic, which was presented by the German mathematician Carl Friedrich Gauss, which states that any integer greater than 1 is either a prime number or can be written as a unique product of prime numbers. Now you need to understand two things out of this statement. One, that a number can be prime, in which case it is its own prime factor, or it can be a composite number, which is a non-prime number, and in that case it will always be possible to express that composite number as a product of its prime factors. And two, there is only one way we can express a number as a product of its prime factors. So now let's dive into the method for finding out the prime factors of a number and therefore expressing a number as a product of its prime factors. We can start by trying to find out the prime factors of 24. We're going to be using what is called the ladder method. There are obviously multiple approaches to finding out the prime factors of a number, but this is the approach that I've personally found easier and one that is more common than others. So when you have a number such as 24, you need to make a ladder-like structure around it, with the number in question, the number which you have to find out the prime factors of, being written in the top right corner. Now think of a prime number which is a divisor or factor of 24. So I know that 2, which is the first prime number, is a factor of 24, and therefore I'm going to write 2 on the left hand side over here. I'm going to divide 24 by 2 and write the value I get over here. So 24 divided by 2 is 12. I am now going to repeat this process again for 12 and then again and again until I get 1 on the right hand side. So 12 I know is a multiple of 2, and therefore 2 goes on the left hand side, and 12 divided by 2, 6 goes on the right hand side. 6 again is divisible by 2, so 2 goes on the left hand side and 3 goes on the right hand side. 3 I know is divisible by itself, and 3 is a prime number, so 3 goes on the left hand side and we're left with 1 on the right hand side. Once I get 1 on the right hand side, I am now going to stop. All of these numbers written on the left hand side are basically the prime factors of 24. If someone asks me to enlist the prime factors of 24, I'm going to answer 2 and 3. But if I'm asked to express 24 as a product of its prime factors, then I'm going to multiply all of these numbers together, which gives me 2 cubed multiplied by 3. Let's now try to find out the prime factors of 84. So we make a ladder-like structure around it. Next we think of a prime number that is a factor of 84, and I come up with 2. So I write 2 on the left hand side. 84 divided by 2 is 42, so it goes on the right hand side, and 42 I know is divisible by 2, so it goes on the left hand side. I'm left with 21, which has 3 as its factor, so 3 goes on the left hand side and 7 on the right hand side, which is divisible by itself, and here comes 1 on the right hand side. So 84 can be expressed as a product of all these numbers, which would be 2 squared multiplied by 3 multiplied by 7. And if I'm asked to list down the prime factors of 84, I can say 2, 3 and 7 are all prime factors of 84. Let's now try to find out the prime factors of 99. We make the ladder-like structure around it. 99 is divisible by 3, which gives us 33. 33 is also divisible by 3, which gives us 11. And 11 is a prime number, and therefore 11 goes on the left-hand side and 1 remains on the right-hand side. So 99 is equal to 3 squared multiplied by 11, and its prime factors are 3 and 11. Let's have a look at a few past paper questions which are going to give us an idea of how this concept is likely to be tested on the actual examination. Express 36 as a product of its prime factors. So it's a very straightforward question, and we're going to use the technique that we just learned. So we're going to write 36 and make a ladder-like structure around it. We're going to write 2 on the left-hand side, and we are left over with 18, which goes on the right-hand side. 18 is also a multiple of 2, so 2 goes on the left hand side and 9 remains on the right hand side. 3, which is a prime number, is a factor of 9, therefore it goes on the left hand side and we're left with 3, and 3 again goes on the left hand side with 1 on the right hand side. So 36 can be expressed as 2 multiplied by 2 multiplied by 3 multiplied by 3, or 2 squared multiplied by 3 squared. The second question states, Umar thinks of a 2-digit number. His number is a factor of 78. It is a prime number. What is his number? Alright, so we know that the number is a factor of 78 and it's a prime number. Therefore, it's a prime factor of 78. And the only other clue that we have is that it is a 2-digit number. So if we find out all the prime factors of 78, we can just simply choose the 2-digit number from amongst them, and that would be our answer. So we're going to use prime factorization to find out all the prime factors of 78, which are 2 and 3 and 13, and therefore we know that 13 is the only 2-digit prime factor of 78 because the other prime factors are 2 and 3. Which are single-digit numbers, so the answer will be 13. Moving on, let's discuss the concept of prime factors. If we have a group of numbers consisting of, say, 2 or 3 numbers, each of the number is going to have its own factors, and there's a very good chance that they're also going to have some common factors. And now we're going to be discussing the method to find out the common factors of a group of numbers and how to find out the highest common factor. So say we have the numbers 48 and 84. The first thing that we're going to do is that we're going to use prime factorization and express these numbers as product of their prime factors. 48 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 3, or 2 raised to the power 4 multiplied by 3. And 84 is 2 squared multiplied by 3 multiplied by 7. Alright, so the first thing we can do is to try to find out the common prime factors, and this can be done merely by observation. In this case, I know that 2 appears twice in the prime factorization of both 48 and 84, and 3 appears once. So I can say that the common prime factors are 2, 2 and 3. When making a list of common prime factors, we'd obviously say it's just 2 and 3. But right now, we're not just trying to find out what are the common prime factors, but also how many times they are repeated. So the common factors of these numbers are going to include 1, because 1 is a factor of every natural number. It's going to include the common prime factors, which are in this case 2 and 3. And it is also going to include the product of different combinations of these common prime factors. So it includes 4, which is 2 multiplied by 2, 6, which is 2 multiplied by 3, and 12, which is 2 multiplied by 2 multiplied by 3. So in short, the common factors of any group of numbers are going to include 1, the common prime factors, and the products of different combinations of the common prime factors. And from this list, I can say that the highest common factor is 2 multiplied by 2 multiplied by 3 equal to 12. Let's have a look at another group of numbers. If we have 3 numbers, namely 42, 84 and 128, once again we're going to use prime factorization to express them as a product of their prime factors, and we get the result as shown. So 42 is 2 multiplied by 3 multiplied by 7. 84 is equal to 2 squared multiplied by 3 multiplied by 7. 128 is equal to 2 cubed multiplied by 3 multiplied by 7. Once again, we're going to enlist all the common prime factors. So 2 is a prime factor for all of these numbers, but it just is common once. Because 42 only has one 2, whereas 84 and 120 have more than one 2's. But since we're only focusing on how many times it appears in the factorization of all of these numbers, we're going to say that it appears just once. Similarly, 3 appears just once and 7 appears just once. So we're going to say that the common prime factors are 2, 3 and 7. The common factors, as I mentioned earlier, are going to be the different combinations of these numbers. So it would be 1, 2, 3, 6, which is 2 multiplied by 3, 7, which is a common prime factor, 7 multiplied by 2, 14, 7 multiplied by 3, 21, and then if you multiply all of the common prime factors together, 2 multiplied by 3 multiplied by 7, 42 is also going to be a common factor. And from this list, we can see that 42 is the highest common factor. However, in most of the questions, the examiner is not going to demand a complete list of common factors, but is rather just going to ask the highest common factor. In that case, a far simpler approach would be to find out all the common prime factors and then to take their product. Because the highest common factor is going to be the greatest product of any combination of these numbers. So if we multiply all of these numbers, that would obviously give us the greatest product. So the highest common factor is going to be the product of all the common prime factors. And when I say common prime factors, you need to remember that if a prime factor is common more than once between those 2 or 3 numbers, then we're going to enlist it twice or maybe thrice, as many times as it is common in all of those numbers. Let's have a look at a few past paper questions. The question states, the numbers 294 and 784 written as products of their prime factors are 294 is equal to 2 multiplied by 3 multiplied by 7 squared, and 784 is equal to 2 raised to the power 4 multiplied by 7 squared. And it further says, find the largest integer which is a factor of both 784 and 294. So basically, it's a very straightforward question which is asking you the highest common factor. So we're now going to make a mental list of all the common prime factors, which I can see are 2, but just one since it appears only once in 294, and it is 7 twice because 7 squared is common in both 784 and 294. So the highest common factor, as I mentioned earlier, would be the product of all common prime factors multiplied together. So it would be 2 multiplied by 7 squared, which is equal to 98. Let's have a look at another question. The question says, written as a product of prime factors, 168 is equal to 2 cubed multiplied by 3 multiplied by 7. Express 140 as a product of its prime factors. So we are just going to use the ladder method and find out that the answer is 2 squared multiplied by 5 multiplied by 7. You do not have to use the ladder method every single time you want to find out the prime factors of a number. The prime factors of a lot of numbers can be calculated mentally, and since there are no marks for ladder method, I suggest that you should try to do it mentally, because with a little bit of practice you're easily going to be able to do it, and that would save you a lot of time. The B part states, find the highest common factor of 168 and 140. Alright, so first we need to find out and make a mental list of all the common prime factors. So we know that 2 is a common prime factor of 140 and 168 twice, because 2 squared is present here and 2 cubed is present here. So 2 squared is a common factor. Next, we know that 7 is also a common factor because 7 is a prime factor of both 168 and 140. Therefore, the common prime factors are 2, 2 and 7. So to find out the highest common factor, we're going to multiply these numbers together, which would be 2 multiplied by 2 multiplied by 7, which is equal to 28. Moving on, the question says, there are 2 square rooms. with their floors measuring 36 meters squared and 64 meters squared. Their floors are lined with the same square tiles. Given that the tiles were used as a whole, find the maximum area of each tile. Alright, so this is a word problem, but at the core of it is the very simple concept of highest common factor. Because the area of these square tiles is going to be a factor of 36 and 64. And since we need to find out the maximum area of each tile, we need to find out not only the common factor, but the highest common factor. So we're going to use prime factorization to express 36 and 48 as a product of their prime factors, which gives us 36 is equal to 2 squared multiplied by 3 squared, and 48 is equal to 2 raised to the power 4 multiplied by 3. So the common prime factors are 2, 2 and 3. And in order to find out the highest common factor, we're going to take a product of the common prime factors, which is 2 multiplied by 2 multiplied by 3. So each tile would measure 12 meters squared. So in this video, we basically covered the entire concept of factors. This is a fairly simple concept and one that is usually taught in junior grades. Some people even use another variation of the ladder method to find out the highest common factors. But I usually suggest against that method since it is not based upon any logical reasoning, but is rather just a hack. This method that I have taught is far more logical and is also the one that Cambridge has been using in its questions a lot. So once you're familiar with this method, it would be really easy for you to answer each and every question regarding factors. Thank you for watching this video. I hope you found it helpful.